find the value of will be with 0 and 1. So what actually happens in elastic? So what all we have to conclude about that one? So this object moving with the speed u, and let this be at rest. A simplified thing. So they'll come and collide. So after collision, they'll undergo deformation. The deformation I'll show like this: m1, m2. Here, impulse of deformation will act here. Because of this will acquire some velocity. Say v1 dash, v2 dash. Why v2 dash? Because the impulse start acting, and it will start pushing it, and somewhere they'll undergo maximum deformation will occur. Call this J like this. Then the impulse of reformation starts acting. V1 dash, V2 dash, and finally so here just make some observation. Look at the initial shape of the object and final. So this is the V1. So what is the net impulse acted on system? 0. So can I conserve momentum? Yes, here also I can apply conservation of linear momentum, inelastic collision. So initial momentum equal to final momentum. So m1 u1 is equal to m2 v1 plus m2. Since all are along x-axis, I'm not showing that bar. When I go and check the final kinetic energy, it will be less than initial kinetic energy. Kf will be less than ki. Where do that energy gone? Converted into the loss in kinetic energy, converted into either deformation of the bodies or heat or sound energy. So the loss in kinetic energy is converted as increase in potential energy of bodies. What all can happen? Increase in potential energy of bodies or heat generated sound energy or even light energy. So in elastic collision, the decrease in loss in kinetic energy, what will be it converted? It can be converted only increase in potential energy of bodies. You can see some deformation is retained. You can see some deformation is retained. Or some sound will come. I think just throw a stone or throw any object. I'm dropping my mobile. Why sound came? Inelastic collision occurred. The decrease in kinetic energy got converted into sound energy. It will be generated. Some cases deform. You do one thing, take some like a body which you can undergo deform, like a floor, hata, mix water, something, throw it. So after collision, what will undergo deform? No, increase in potential of bodies. Heat will be generated in some cases. Sound maximum, what we notice, and light energy also. You do one thing, night you go and look at any boulder, big boulder. You take some stone. When you strike it, you'll get a spark, no? You'll get a light spark. So nothing but a part can also be converted as light energy. So what will happen? All four can happen, or any two, any three. So there's nothing. It all depends upon the situation. If the rigid body, It's almost very near to rigid body. Increasing potential energy very less. Then the decreasing potential, decreasing kinetic energy of system output will be converted into either sound or light. If the body is less rigid, then what happens? The light will not be possible. You take some soft object or you take any sponge ball, you throw it against wall. We don't get light energy, no, and we hardly get sound energy. The maximum will be increasing potential. It all depends upon the type of surfaces which they come and collide. With the bodies which are almost rigid, they collide, we get these two, sound, light. If the bodies are near to elastic, then we'll get these two, or sometimes all four. So it all depends upon the nature of colliding bodies, like which energy will be dominant. This is what happens in the inelastic collisions here. Means now, sir, can I apply still the same formula? As even the formula is applicable, quotient of restitution here also. So what is the formula? E is equal to velocity of separation by velocity of approach. Of course, u2 is 0 in this particular given thing. Substitute here, you get it. So when you check this and check the value of E, you'll end up with less than 1. But sir, how do I come to know? Because V1, V2 are unknown. What is the only thing that will help us? Conservation of linear momentum. But if you check it here, both V1, V2 are unknown. What about other equation? The other equation, practically they verified it. When they checked V1, V2, no, and they checked the initial kinetic energy, final kinetic energy. Final kinetic energy less than initial kinetic energy. So some energy lost, where it has gone. Okay, some other form. Then after getting the final kinetic energy, they brought V1, V2, and the substituted here, they got E less than 1. So with this, what I can conclude now, the value of E for inelastic collision will lie between 0 and 1. Elastic collision equal to 1. Inelastic, anywhere between 0 and 1. And for any collision, you can define it. There's nothing problem here also. So now here after inelastic collision comes. Conservation of linear momentum. Yes, you can apply. Conservation of kinetic energy. No. Then how to calculate V1, V2 unknown? Quotient of restitution formula. I think this is going to really help us a lot. This is really going to help us a lot here. So some deformation converted as increasing potential of body, or some deformation will be retained. This is what happens in inelastic collisions here. Okay, after this, we'll go for now we'll go for the perfect inelastic collision. We don't have perfect elastic, just elastic, that's all. Elastic means equal to 1. Elastic, perfect inelastic, E will be 0. The two objects they're moving with a velocity u1, u2, so they'll undergo collision and they'll move with a common velocity. Then can I conserve momentum? Yes, initial momentum equal to final momentum. So m1 u1 plus m2 u2 equal to m1 plus m2 into v. And what is that v? Velocity of center of mass. So after collision, the objects will move with a common velocity that is equal to velocity of center of mass only. What is v? V is also you can call velocity of center of mass. Getting the idea? So this is nothing but equal to velocity of center of mass here. Now, if you check Kf, Kf will be less than Ki. What happened at delta K? The decrease in kinetic energy got converted into heat, potential energy, or sound, or light. It all depends upon nature of bodies, that which energy will be dominant. What is value of E? E will be 0, because what is the velocity of separation, relative velocity of separation? 0. So the value E will become 0. Perfect inelastic. And there's no rule that For E equal to 0, the body should stick to each other. When we go for two-dimensional collision, you can see that though they collide, they don't stick to each other. In one-dimensional collision, they must stick to each other. So in 1D collisions, for E equal to 0, the bodies will stick together. The bodies will stick. Okay, we'll do one thing. The bodies will get stuck and move with a common velocity. And move with a common, what is that common velocity? Velocity of center of mass. In two dimension, they need not to stuck together. Later on in the two dimension we discuss now. Now it's not needed. Just have an idea. In one dimension, yes, perfect inelastic collision, they'll stick together and they'll move with a common velocity. What all the decrease in potential get converted into any of the form, depending upon the type of colliding bodies. Okay, let's focus on that quotient of restitution. Once again, we'll come back. The value of E, quotient of restitution, what all depend. Nature of, so like a E will define now. Analysis of E. Well, it depends on the material, the type of material, anything. So shall we